In this lesson, we're going to go over domain of square root and rational functions. First, what we'll do is we'll understand and talk a little bit about function notation. We'll understand what domain is, and then we'll find the domain of a square root function and write that in interval notation. And then for rational functions, we'll find out what the excluded values from the domain are. First, a little bit about functions. So in this section and the next, we're going to be talking more about functions. The next, we'll dive a little deeper, but I wanted to talk about function notation. So function is a relation between x and y. So what you were used to seeing before is something like y equals 3x plus 2. Now we're seeing f of x is equal to 3x plus 2. So I like to think of each part in a different way. So f, to me, is just the name of the function. You could call it g, h are common. I could call it m for Megan. You could call it whatever the first letter of your name is. But f is the name of the function. X is the input value. So you plug a value in for x and you'll get a value out for y. And then once you do that, f of x equals something will be your output value. Okay, but mainly for this section, I wanted to talk about the notation because that'll come up for domain. And in the next section, we'll take a deeper dive into functions. So domain of a function. So what is domain? Domain are the x values that you're allowed to plug into the function to get a valid output. So the two functions we'll be talking about today are square root functions and rational functions. With square root functions, remember, you can't take the square root of a negative number. So whatever values for x that we plug into a square root function, we have to make sure that we keep whatever's under the radical positive. For rational functions, we're not allowed to divide by 0. So when we're finding excluded values, we're finding out what values would make the denominator 0, and those are not allowed to be in the domain because we can't get a valid output. So example 1, find the domain, write your answer in interval notation. So with square root functions, we need whatever's under the square root to be positive. Another way of saying that is it could be 0 or higher. So what we do is we take whatever's inside of the square root and set it greater than or equal to 0. And now we remember solving inequalities. We solve this for x. Divide by 8. So what this is telling us, that's a negative sign. Let me make that a little bit more clear. Is that x must be greater than or equal to -4. If you plug in -4, -4, -3, -2, -1, and so on, in for x in the function, you'll get an output. Okay, and so the second piece of this is write your answer in interval notation. When you see interval notation, you want to start thinking of parentheses and brackets that we previously talked about. I'm going to show you how I come up with interval notation. You may just be able to see it, but I'll give you a way to do it. What I would do is I would graph this on a number line. -4 is over here. Greater than or equal to -4 means that there's a closed circle at that endpoint, and values that are greater, my arrow would point to the right. So now what I'll do is I'll take this line that I wrote, or ray rather, at -4 and higher and write it in interval notation. Interval notation always goes smallest to biggest. So the smallest value is -4, and this can go up to positive infinity. So my domain in interval notation is -4 to positive infinity. Example 2, find the domain. So we'll start the same way. We'll take 7 minus x greater than or equal to 0. Subtract 7. This becomes -x is greater than or equal to -7. And then we divide by -1. Remember, when you divide by a negative, you must change the inequality symbol. So this is x less than or equal to 7. And so what I'm going to do then is graph this on a number line. Less than or equal arrow points to the left. And so for interval notation, it's smallest to biggest or left to right. The smallest value is -infinity. The biggest value is 7. So that would be my domain in interval notation. Example 3, I just wanted to talk about this one for a little bit. Notice x is the only thing under the radical. The +3 is on the outside of the radical. So when we apply the principle of setting whatever's under the square root sign greater than or equal to 0, we're only concerned with what's under the square root, which would be x. Okay, so in this case, it's just x greater than or equal to 0. And then if you were to write that in interval notation, it would be 0 to infinity. Next, we're going to talk about all the values that are not in the domain of the function. So pay attention to what the directions are saying here. The values are not in the domain of the function. So when we have a rational function or a function that has fractions, we have to make sure that the denominator does not equal 0. Okay? So what you can do is you can take a look at it and think, what value of x makes the denominator 0? That would be x is -1. Or what you can do is you can set the denominator equal to 0 and solve to find the excluded values. Okay, so in this case, the excluded value is x equals -1. Example 5, find all the values that are not in the domain. In order to figure out what the denominator is equal to, we have to factor. Okay, so this becomes x plus 8 over x plus 8 times x minus 7. Okay. So then the two values that would make the denominator 0 are -8 and 7. The reason why I wanted to talk about this example is when you're talking about domain of a function, you don't cancel. Domain is always taken from the original function that you're given. So for instance, and I'm going to write it in red to show you that it's not correct, if you were to cross off x plus 8 and get 1 over x minus 7, the only value you would tell me that's excluded is 7. However, you take the values of the domain from the original, so x cannot be -8 or 7. Example 6, find all the values that are not in the domain of the function. So again, we'd take a look at our denominator and find out when it equals 0. Okay, this doesn't factor. The temptation is to factor it as the difference of perfect two squares, but this would be x squared minus 49. But take a look at it. You're taking a number and you're squaring it, so that's going to be positive, and then you're going to add 49 to it, which is still going to be positive. So this will never equal 0, so here there's no excluded values. Thank you for watching. If you have any questions, please feel free to reach out to me.